Okay, good morning, good evening, good afternoon, whatever time it is, and wherever you are. I hope this finds you safe. I hope this finds you healthy, and I hope this finds you at least 6 feet away from other people in and around your home or neighborhood or wherever. Today we're going to talk a little bit about classes. Oops, let's close that down here. Okay, and it is just an introduction. All right, for the main reason, of course, is that there are other classes that dive more into what classes are all about, how you write them, how you include them. But this lecture is one of the learning outcomes, at least an introduction of this content. And you should recognize that if you know stuff from this lecture, you'll be able to get the questions or information that is required on the final exam all correct. So data types. Well, we've seen a lot of data types. And throughout the semester, we've seen ints and floats, we've seen doubles and chars, we've seen a whole bunch of other things. And we have created these variables to store certain data types by declaring those variables in at least these two ways. And we're going to spend today talking about, well, C++ a little bit, as we will on the very last lecture of the class, just to remind ourselves that this is a course with C++ and MATLAB, and on the final exam there will be questions about both of those languages. So we've seen that an integer can be declared, and it can be, in this particular case, initialized with the values 3.57 at the same time that we're declaring a double called endtime. And so variables declared this way are fairly basic. There's no special features, there's little flexibility, we always had to declare them before we use them. MATLAB sometimes has some advantages because you can declare them at different times, and in fact you can allocate some memory for those variables at the moment that you use them. But there's this question that if we could create our own data types and give them plenty of features, well, what would we have? What would we have them do? What would they include? Okay, and so we've got one example here where we have a variable type, and the variable type is house, and the variable identifier, the name of the variable, is called my house, and so this of course is a declaration. Okay, and it's an object, okay, because this house is actually more than just kind of a data type. It's kind of a special data type with, well, special powers. And what are those special powers? Well, we've seen similar ones before. We can actually have functions that are related to these particular variables, and not just variables, but objects. Okay? So what we have is that the data types themselves, okay, have special powers, and in particular, they're going to have things like calculate the area, or calculate the height, or some other information that's related to this particular object. So we can define our own data types in C++, okay? And so we use what's called a class. It's a mechanism that allows this programmer, any of us, to define a new data type. And so we say that a house is a class, okay? And then when that sort of class has been initiated with some sort of variable name, okay, we call it an object. All right, so it's defined, it's declared, and we sometimes also refer to as an instance. Okay, so in terms of the variables, right, we might have an integer, which would be the class type, okay, the new data type, and then we'd have the specific variable name, and of course we're going to refer to that as the instance or the object. Therefore, my house on the previous slide is an object or instance of the class house. All right, well, we've already used classes before, and one of them was most recently called the vector class. And there was kind of a special way that we declared it. Okay, and so we use these little symbols right here. Okay, and that was of course going to be the data type, the primitive data type inside the vector. Okay, and then of course we had the variable identifier, the name of that particular vector. But ultimately this list, or rather this name right here, was an instance of the class vector. We've also worked with ifstream class, and so we've seen something like this where we declared a ifstream object called myFile, and then with myFile, well, we used a bunch of functions that were related to that particular object or instance of the class ifstream. And same thing up above, where if list was the instance of the vector class, well, then it came with a whole bunch of powers. We called these functions, and we could get the size of any particular instance of the vector class. Same sort of thing, we could have some sort of ifstream object, and we could assign some sort of data file to it by using the open function, and eventually after working with it we could close it. So what did all these classes kind of have in common? Well, they both, of course, defined a new type of object, and they both required a header file. Okay, and this is where the class information is declared. So if you recall, right, we always have to declare or define or set up something in C++ before we use it, before we call it, before we use it in some sort of expression. And the same sort of thing happens then with a class, where inside the header file, we need to include a header file in order to use it later on. So with cout and cin, which are types of classes, they're different instances, okay, for the IOStream object, we had to have a, well, hash include statement before. Okay, and so we had these little symbols right here. Maybe it was like IOStream. All right, and of course, after we declared this, then we could use cout, we could use cin, we could use some other things as well. Okay. Now all of these have some built-in functions to help us deal with the objects in the class. Okay, and in fact, cout and cin, we kind of explored a little bit of those because we had set precision and set w and set some tabbing and that sort of thing. But we can also create our own classes with new data types and new functions. Okay, so if you don't like the vector class, or if you don't like the IOStream class, or if you don't want to use the file fstream class, or rather the header files with those classes, well then you can define your own. So how do we declare our own? Well, we have two things. We need a class declaration and then a class implementation. This is kind of similar to what we have with functions, where we have kind of a function prototype. Okay, and then a function definition. The parallel then is kind of this area right here, where a class declaration is kind of where you set up the class, its parts, its skeleton, important things related to it, and then you define it later on with a not function definition, but a class implementation, which is then defining the different member variables and some other things associated with the class. So class declarations, as I said, are written in these header files that have to be included, okay, with this hash include sort of statement. And what's going to be a part of them are what's called member variable declarations, so information or data types inside these classes, and also some member functions. So of course with the vector class, we could use the dot size or dot append or dot insert, and those of course are going to be member functions inside the vector class. The second part of a user-defined class is with the class implementations, and these are written in C++. They're with source files, which means we're going to have the file extension CPP, whereas header files are going to have .h files. And inside these source files, well, we're going to, well, define these member functions. Okay, so the class declaration side, first of all, we need to create a separate header file. We're going to show this in examples here in a second, by way of example. And it's going to be called exactly classname.h, which means then that if we want to have a class name called, let's say, vector special or something like that, okay, we'd have to have some sort of header file called, well, vector special.h. And then vector special, this thing right here, is the class name. Okay, and this must be included with a hash include statement in any C++ source file that we use for the class. Okay, so we have to have the class name, all right, we have to have the declaration of the member variables, and then we're going to have all the function prototypes. Again, this is kind of a prototype of a function, but in this case it's a prototype of a class, and so we're setting up the skeleton, we're setting up what the class might look like and how it can be used, but we're not going to define necessarily anything inside of it quite yet. Alright, so this is what's found in .h file, right? We said we have the class name right here, but we have to have this comment right here which defines that this class name is of type class. Okay? And then we separate these things, so we have a little curly bracket right here and right here to open and close it, very similar to a function. Okay, and then we have two separate sort of sections inside class definitions, or rather I should say declarations. One of them is public, okay, and these are the functions and variables that can be accessed by those using the class. All right, so these are the things that are allowed to be accessed, where the users can use them, can look at them, can access them. And then there's also kind of the private side of things, where these are the functions and variables that cannot be used. They cannot be accessed by users. Okay, they can only be accessed by developers. All right, and so quite often we might have some sort of public door, a window or access panel, okay, that's going to access some of the private variables, okay, the other things that we want to keep protected. And class declarations must be terminated with a semicolon. Okay, so you can see that right here, there's a little semicolon, and so if you think about it, a class declaration is kind of like a statement, where it must be ended with a semicolon. All right, if that's the class declaration, well, the class implementation, okay, needs to be found in a CPP file, not a .h file. All right, and it's going to have the class name, okay, separated by 2 colons right here, and then the functions. And these functions are going to be the same functions that were declared inside the class declaration file, the .h file, which means that there's going to be a function 1, for example, that will be replaced with, say, size, okay, if it was the vector class right here. Okay, same sort of thing. If there was an append function, we would need to have append right here in place of this function, and then right here it would be vector. Okay, so the class name then is going to be in this spot right here, and then the functions are going to be right here, and then of course they're going to be defined in the same sort of way, where you're going to have an open and close bracket just like you would with a normal function definition inside of main files. Okay, and I think I already mentioned it, but again, recognize that there's a double colon separating the class name with the function. All right, well, we're almost to our last slide. In fact, the last slide is questions. So we're going to spend some time in the next part talking a little bit about, well, how do we generate these classes? And so we're going to have a class, okay, called student record, okay, and it's going to contain the following information. You have a GPA, okay, that might be a float, for example. Okay, that's better to have a float than an int. Total credit hours, well, total credit hours could be an integer, okay, but if you can have 0.5 credit hours, maybe that should be a float as well. And then student ID. Well, student ID is always going to be an integer. Okay, so we're going to also have an integer right there. And then we're going to have member functions. All right, so if you were transferred into BYU, you might have some sort of GPA. And so if we make some sort of student right here, well, we're going to have to set their GPA, maybe their incoming GPA. Maybe they're transferring from BYU Idaho, and so they're going to have a GPA of, I don't know, 3.2 with how many hours they have and an ID number. And so we're going to establish, okay, a particular data type called a student record. So there's going to be an instance or an object of type student record with some sort of name, and it might be, I don't know, say Billy or what have you. Okay, and we'll talk about this here in the example here in a little bit. And then after a particular semester, you might have additional classes and get some credit and update your GPA and some hours, and so you also want to have a function that recalculates the cumulative GPA. Now, we're going to talk a bit about the private and the public functions, because you don't want to have anyone just mess with your GPA. You want them to follow specific protocols on how to update your GPA. And of course, we're given some opportunities across BYU to take a pass-fail or to keep our GPA as it is. So there's lots of exciting things we can kind of talk about in terms of this, but what's ultimately necessary is that if you have some sort of student record on the servers at BYU, you want to make sure that the computer IT specialists are respecting your data, keeping it protected, and making sure that only the right people have access to it using what we'll define as functions in the soon-to-be example. And then finally, we'll talk a little bit about get functions, where if you do want to update or take a look at what you have right now, you can also apply a function and find out how well you're doing in terms of your GPA, how many credit hours you have, and of course, check your ID number if you want. And so in the next part, we're going to go into Visual Studio and explore how to generate a class and work with them using class declaration and class implementation files.